So now we're solving trig inequalities. This is our last section of notes in chapter 5. First thing we need to do is get critical numbers. And we get critical numbers by solving for x, treat the equation as an inequality as an equation, solve for x. But also look for where there are vertical asymptotes. So what that means is for critical numbers, first we solve when is 3 tangent x equal to 3. All right, so that's when tangent x is equal to 1. That happens in quadrants 1 and 3 with a reference angle of pi over 4, like we talked about yesterday. So the first two critical numbers are pi over 4 and 5 pi over 4. But we also have to think about where is tangent x undefined on this interval. Normally it's like, plus or minus pi over 2 because of the graphing that we've done. But on this interval, it's pi over 2 and 3 pi over 2. And we need to get all of those numbers on a number line. So 0, 2 pi, plot them in order too. So the first angle you hit is pi over 4. Then if this helps, put a unit circle on here. So pi over 4, then pi over 2. All of these are open circle. Pi over 2 is an asymptote if you want to draw that in. And then 5 pi over 4. I'm not really doing spacing very well here. And then 3 pi over 2. And then finally back to 2 pi. So what we need to do when we're picking intervals is look in between these values. And I think sometimes it's easier to see on a unit circle. So now remember, 0 is included in the solution set. And you're not comparing for when is tangent positive or negative. What you're looking for is back to the inequality. When is 3 tangent x greater than 3? Or when is tangent x greater than 1? I think it's easier to compare to 1 than it is to multiply something by 3 and compare it to the number 3. So let's look at this. This is what we're comparing when we test into. So I'm going to start with 0 for the first interval. Tangent of 0 is equal to 0. Is 0 greater than 1? No. So that section's out. That's false. Pick something between pi over 4 and pi over 2. It's easier to visualize here. So my first angle was 0. My second angle is going to have to be pi over 3, right? So what is the tangent of pi over 3? Tangent of pi over 3, the y over the x is radical 3. Is radical 3 bigger than 1? Yes, because 1 squared is 1. So radical 3 is 1 point something. So that's true. So here's a solution set. Next thing, I have this big range here. I can pick between pi over 2 and 5 pi over 4. So I'm going to pick pi because that's a nice easy number. Tangent of pi, the y over x there is 0. Is 0 greater than 1? No. If we check between 5 pi over 4 and 3 pi over 2, the option down there is 4 pi over 3. It's the only non-calculator option we have. So tangent of 4 pi over 3. Tangent of 4 pi over 3 is equal to positive radical 3 again. That's greater than 1. So yes in this section. All right, and then if we pick something between 3 pi over 2 and 2 pi, I could pick the 7 pi over 4. The tangent of 7 pi over 4 is equal to negative 1. Is that greater than 1? No. So we have two solution sets here, pi over 4 to pi over 2, and 5 pi over 4 to 3 pi over 2. If I didn't put the asymptotes in, I might have accidentally said that pi over 4 all the way to 5 pi over 4 was a solution set. But if we're looking between values, pi over 2 to 5 pi over 4, that doesn't satisfy that inequality. Okay, now It's also pretty likely that we would see this as a calculator problem, which makes life much, much easier. So use a calculator for this one and round to 3 decimal places. So using a calculator, I'm going to put the left side in Y1, and I like to do the right side in Y2, um, just because, I don't know, you could also just look at what it hits the Y-axis, but I think that finding the intersection is faster than going left, right, and calculating a 0. Just personal calculator preference there. So make sure you're in radian mode, first of all. Go to y equals. How do we type in sine squared? So we have to type in sine x in parentheses like this, and then square it, plus 5 sine x, close that angle, plus 1. And like I said, I just like to put in 0 for another one of the values. And as far as the window, we should be setting the x min to 0 and the x max to 2 pi. Doesn't really matter what you're going to count by. I'm just going to leave that. And then for the y min and max, I don't really know what the y min and max is going to be for this. So I tend to do like, I don't know, -5 to 5. I could probably do zoom fit, but I'm just going to kind of play with the window like that. And I can adjust if I need to. I don't really care about the max and the min. I just need to see the intersection points. So you just need to make sure that 0 is in your Y window. So there are 2 points of intersection here, but look at the graph. Let's sketch what we're seeing on the graph. So here's the line 0. This graph does something like this. So it is, open circle, it is on this section where the graph is below 0. Everywhere else it's above. So I'm just going to find, like I said, I'm going to do the intersection of 0 and the curve. That's faster, I think. So at one value, I get the x. Actually, let's write this down. So this is 3.352. And then this value here, got to get my cursor closer to the other side of the graph there. That's probably good. And then enter, enter, enter. So 6.073. And so if I solve for the solution set in interval notation, I get 3.352 to 6.073. That's the solution set in radians for this problem as well. All right, so obviously without a calculator, this takes a lot of like our entire chapter 4 skill set. So it's a pretty good problem. But I don't expect for us to have, 20 of these on an AP exam. So come into office hours if you'd like extra practice, and just make sure that you can do both the non-calc and the calc.